our three special triangles. To get a grasp on our first two special triangles, we're just going to start off with a very simple triangle, an equilateral triangle with side length 1. An equilateral triangle is a triangle where all side lengths are equal and all angles are equal. Now I'm just going to find the midpoint of line segment CB. So the midpoint of line segment CB is D. And I'm going to connect vertex A with point D, sort of like this. Essentially, we're cutting the triangle exactly in half. And this could lead to some interesting consequences, namely, if this angle here was 60, well, now line segment AD bisects this angle. In other words, it cuts it in half. So what can we conclude? We can conclude that that angle's 30 degrees. Further, since we bisected line segment CB, what can we conclude? Well, CB had length 1. So since we bisect it, which means cuts in half, we get line segment CD is now 1/2. So I guess our next step would be naturally to ask, or perhaps not so naturally, what is the length of AD? So pause the video, and I would like you to come up with side length AD. So I'm hoping that you found out that line segment AD was √3/2. So this is √3/2. So what I'm going to do now is I'm just going to simply call the red triangle what you see on your right-hand side. That is really triangle ACD. What we see is this angle right here is 30 degrees. The hypotenuse is 1. The side opposite 30 degrees is 1/2, and the side adjacent is √3/2. Taking a look at the green triangle, well, the green triangle is just a reoriented red triangle. So although there is no 30 degrees listed in the green triangle, it's actually the uppermost angle, leaving the base angle here, theta is equal to 60. We have our hypotenuse is equal to 1, and the bottom side length is 1/2. So the adjacent side to 60 degrees is 1/2. The side opposite 60 degrees is √3/2. These triangles are incredibly important. We'll be using these later on when we take a look at the unit circle.